October 14, 1942, Henderson Field, Guadalcanal, 6:30 a.m. The acrid smell of cordite still hangs in the tropical air as the first rays of sunlight pierce through the smoke-filled morning. 53 massive craters pockmark what was, just hours before, the most important airstrip in the Pacific. Twisted fragments of steel matting jut from the earth like broken teeth. Shrapnel glitters across the runway like deadly confetti. Lieutenant Commander Paul Blunden wipes sweat and soot from his brow as he surveys the devastation. The Japanese battleship bombardment, followed by wave after wave of bombers, has turned Henderson Field into what looks like the surface of the moon. Fuel fires still burn in the distance. The smell of aviation gasoline mingles with the sweet, cloying scent of tropical vegetation torn apart by 14-inch naval shells. In the growing light, Marine pilots pace anxiously near their Wildcat fighters, still intact but useless without a runway. Above them, the distant drone of approaching engines signals the return of American bombers, their fuel gauges dancing near empty after the night's missions. They need a place to land, and they need it now. But Blunden's men are already moving. Before the last bomb fragments have stopped falling, before the final fires are extinguished, the Seabees of the 6th Naval Construction Battalion are racing onto the field with trucks loaded with crushed coral and steel matting. What happens next will astonish the enemy, revolutionize military engineering, and change the course of the war in the Pacific forever. By the autumn of 1942, the Pacific War had reached a critical juncture that would determine the fate of nations. The Japanese Empire, having swept across the Pacific like a conquering tide, controlled an area spanning from the Aleutian Islands to the edge of Australia. Their strategy was simple, yet devastating. Highly effective. Establish a chain of fortified airfields across the Pacific, creating an impenetrable barrier that would keep American forces at bay while Japan consolidated its vast new empire. The key to this strategy lay in air power. Whoever controlled the skies controlled the seas below, and whoever controlled the seas controlled the war. Japanese military planners understood this fundamental truth, which is why they had begun constructing a critical airfield on a humid, jungle-covered island in the Solomon Chain called Guadalcanal. This airstrip, located at Lunga Point, would serve as a dagger pointed directly at the Allied supply lines to Australia. For the Americans, the threat was existential. If Japan completed this airfield and began operating bombers from it, the lifeline to Australia would be severed. American forces in the Pacific would be isolated, cut off from reinforcements and supplies. The war in the Pacific could be lost before it was truly begun. This realization sparked the first major Allied offensive in the Pacific theater. On August 7, 1942, the 1st Marine Division stormed ashore at Guadalcanal in a desperate gamble to seize the unfinished Japanese airfield. The Marines succeeded in capturing the strip, but holding it would prove to be another matter entirely. The Japanese were determined to retake what they saw as strategically vital real estate, and they would throw everything they had at this small patch of jungle real estate. The captured airfield was hastily renamed Henderson Field, after Major Lofton Henderson, a Marine pilot killed during the Battle of Midway. But names meant little when the runway itself was barely functional. The Japanese had abandoned it in such haste that it remained largely unfinished, unpaved runway that turned into a swamp of mud during the frequent tropical downpours. Heavy rains created treacherous conditions that claimed more American aircraft through accidents than enemy action. The Marines who captured the field found themselves in possession of what amounted to a 3,800-foot strip of dirt that was more obstacle than asset. The runway lacked proper drainage, had no hard surface, and possessed none of the support facilities necessary for sustained air operations. Fuel had to be stored in primitive conditions, ammunition dumps were hastily constructed affairs, and maintenance facilities consisted of little more than canvas tents and portable equipment. Yet this crude airstrip represented the most important piece of real estate in the Pacific. From Henderson Field, American fighters could provide air cover for the vulnerable Marine positions. More importantly, American bombers could strike at Japanese shipping and installations throughout the Solomon Islands chain. Control of Henderson Field meant control of the entire Guadalcanal campaign, and control of Guadalcanal could determine the outcome of the war in the Pacific. The Japanese understood this as clearly as the Americans did. Within days of losing the airfield, they began planning its recapture. Japanese forces on the island began organizing for counterattacks while the Imperial Navy prepared to support them with massive bombardments from the sea. Japanese aircraft from bases at Rabaul began daily bombing runs against Henderson Field, determined to render it unusable even if they could not immediately recapture it. Into this desperate situation came a group of men who would revolutionize the very nature of military construction and engineering. They were called Seabees, a phonetic shortening of their official designation as Naval Construction Battalions, or Seabees. These were not ordinary sailors or traditional military engineers. They were something entirely new in the annals of warfare, construction workers who could build and fight with equal skill. The concept of the Seabees had emerged, from hard lessons learned early in the war. When Pearl Harbor was attacked, civilian construction workers had been building and maintaining military facilities across the Pacific. These civilians, while skilled at their trades, had no military training and could not defend themselves or their work when war came. The fall of Wake Island had driven home this lesson in the most brutal way possible. More than 1,000 civilian construction workers had been captured when the island fell to Japanese forces. Many would die in captivity, and those kept on Wake Island to continue construction work were eventually executed by their captors. The Navy realized it needed construction workers who could defend themselves and their projects. Thus was born the concept of the Naval Construction Battalion. These units would combine the technical expertise of skilled construction workers with the military training necessary to operate in combat zones. Their motto became, Construimus batuimus, we build, we fight. Admiral Ben Morrell, known to his men as the King Bee, led the recruitment effort. Rather than trying to train sailors to become construction workers, Morrell went directly to the source. He recruited experienced construction workers, welders, heavy equipment operators, electricians, and engineers from civilian industries across America. Many of these men were veterans of the great construction projects of the Depression era, the Hoover Dam, the Golden Gate Bridge, the Tennessee Valley Authority projects. They brought with them not just technical skills, but an American can-do attitude that would prove invaluable in the challenging conditions of the Pacific War. The first Seabees were older than typical military recruits, with an average age of 37. Some were in their 60s, grizzled veterans of construction sites across America who had volunteered to serve their country. What they lacked in youth and physical conditioning, they more than made up for in experience and expertise. These men had built America's infrastructure during the boom years of the 1920s and the challenging years of the Great Depression. They understood how to work with limited resources, how to improvise solutions to complex problems, and how to get things done under pressure. The Seabees received military training in small arms and combat tactics, but their real weapon was their unmatched ability to build. They could construct airfields, roads, bridges, fuel storage facilities, ammunition dumps, hospitals, barracks, and fortifications. More importantly, they could do all of this under combat conditions, working through air raids and artillery bombardments with a determination that amazed both allies and enemies. Their training emphasized speed and efficiency. Traditional military construction methods were designed for permanent installations built under peacetime conditions. The Seabees developed techniques for rapid construction using prefabricated materials and standardized designs. They pioneered the use of Marston matting, interlocking steel planks that could create a hard runway surface in a fraction of the time required for traditional concrete or asphalt paving. The Seabees also developed revolutionary logistics systems. They took control of loading and unloading supply ships, ensuring that materials and equipment arrived in the order needed for construction projects. They created standardized toolkits and equipment packages that could be rapidly deployed to any location. Most importantly, they developed maintenance and repair procedures that could restore damaged facilities in record time. By the time the 6th Naval Construction Battalion arrived at Guadalcanal in September 1942, they represented the cutting edge of military engineering. They brought with them not just the tools and materials needed to improve Henderson Field, but also the experience and determination necessary to keep it operational under the most challenging conditions imaginable. The human element of the Seabees' achievement at Henderson Field cannot be understated. These were men who had chosen to leave comfortable civilian jobs and stable families to serve in some of the most dangerous and challenging conditions of the war. Many were fathers and grandfathers, men who could have easily avoided military service due to their age or essential civilian occupations. Yet they volunteered, driven by a patriotic duty and a professional pride that would not accept defeat. Seaman Second Class Lawrence Myers exemplified this spirit. During one of the daily Japanese air raids on Henderson Field, Myers grabbed a nearby .50 caliber machine gun and fought back against attacking Zero fighters. His quick thinking and courage earned him the Silver Star, though the honor came posthumously when he was killed in action 2 weeks later. Myers had been a construction worker in civilian life, not a trained anti-aircraft gunner, but when his airfield came under attack, he responded with the same determination he would have shown protecting any job site. The technological revolution the Seabees brought to Guadalcanal centered on their systematic approach to rapid repair and construction. Traditional military engineering doctrine called for careful planning, detailed surveys, and methodical construction techniques. The Seabees threw this doctrine out the window, developing instead a system of rapid response that treated airfield damage like any other ruction emergency. They pre-positioned repair materials at strategic locations around Henderson Field. Trucks loaded with crushed coral, steel matting, and construction tools were kept ready at all times. When bombs fell, these trucks would race to the damaged areas before the dust had settled. Teams of Seabees would swarm over the craters, working with the efficiency of a professional construction crew and the urgency of men whose lives depended on getting planes back in the air. The tactical importance of their work extended far beyond simple runway repair. Every hour that Henderson Field remained operational was an hour that American fighters could remain in the air, protecting the vulnerable Marine positions around the airfield. Every successful landing by a damaged bomber represented aircrew saved and aircraft preserved for future missions. The Seabees understood that their work was literally a matter of life and death, not just for themselves but for every American serviceman on Guadalcanal. Their innovations in construction techniques would influence military engineering for decades to come. The Seabees developed modular construction methods that could be rapidly deployed and just as rapidly moved to new locations. They pioneered the use of prefabricated components that could be manufactured in the United States and assembled in combat zones. They created standardized designs for everything from ammunition bunkers to aircraft hangars that could be built quickly and efficiently under field conditions. The psychological impact of their work was equally important. The knowledge that Henderson Field could be rapidly repaired gave American pilots and ground crews confidence to continue operating under the most dangerous conditions. Even when Japanese bombardments turned the runway into a moonscape of craters, everyone knew that the Seabees would have it operational again within hours. This confidence translated into continued air operations that kept pressure on Japanese forces throughout the Solomon Islands campaign. The moral dimension of their work also resonated throughout the Pacific theater. Here were American construction workers, many of them middle-aged civilians, outworking and outbuilding professional military engineers from one of the world's most advanced industrial nations. The Japanese had built their Pacific strategy around the assumption that their island fortresses would be impregnable, that any American attempt to establish bases would be slow and vulnerable to counterattack. The Seabees shattered these assumptions with their unprecedented construction speed and their ability to keep facilities operational under constant attack. From the enemy perspective, the American construction capabilities at Henderson Field represented a complete contradiction of everything they understood about warfare and engineering. Japanese military doctrine emphasized careful preparation, meticulous planning, and the construction of permanent fortifications designed to withstand extended sieges. Their own engineers were highly skilled professionals who built to exacting specifications, creating installations that were marvels of military engineering but required months or years to complete. The speed with which Americans could repair bomb damage and construct new facilities defied Japanese comprehension. Intelligence reports from Guadalcanal described runway repairs that seemed impossible even by Japanese standards. Their pilots reported bombing Henderson Field into complete unusability, only to return the next day to find it fully operational again. Japanese naval commanders expended enormous resources in repeated bombardments of the airfield, convinced that surely this time they had inflicted irreparable damage, only to discover that American aircraft were taking off and landing within hours of the attack. Japanese prisoners captured later in the war would describe their amazement at American construction methods. They had been trained to think of military construction as a lengthy process requiring extensive preparation and specialized equipment. The sight of American bulldozers and construction crews working under fire, repairing damage almost as quickly as it could be inflicted, challenged their fundamental understanding of military capabilities. The speed factors that enabled these remarkable achievements went far beyond simple construction techniques. The Seabees had revolutionized military logistics, ensuring that repair materials and replacement equipment arrived exactly when and where they were needed. They had developed training programs that cross-trained personnel in multiple specialties, meaning that any Seabee could perform basic construction tasks regardless of his primary specialty. Communication systems played a crucial role in their rapid response capabilities. The Seabees established direct communication links between airfield operations and construction crews, ensuring that damage reports reached repair teams within minutes of an attack. They developed standardized damage assessment procedures that allowed them to quickly prioritize the repair efforts and allocate resources where they were most needed. The logistics revolution the Seabees pioneered extended throughout the Pacific Theater. They took control of cargo loading and unloading operations, ensuring that supply ships were loaded in the order that materials would be needed for construction projects. This seemingly simple innovation eliminated the delays and confusion that had plagued earlier construction efforts, where critical materials might be buried under tons of less essential supplies. Their development of prefabricated construction components allowed for unprecedented construction speed. Rather than building everything from scratch in combat zones, the Seabees could assemble pre-manufactured components that had been built under ideal conditions in American factories. Marston matting exemplified this approach. These interlocking steel planks could be manufactured in large quantities in the United States, shipped to combat zones, and assembled into runway surfaces in a fraction of the time required for traditional concrete or asphalt paving. The Seabees also pioneered the use of standardized construction designs that could be rapidly deployed anywhere in the Pacific. Rather than designing each facility from scratch, they developed standard plans for everything from fuel storage facilities to aircraft hangars. These standardized designs could be modified for local conditions while maintaining the speed advantages of proven construction methods. Quality control systems ensured that rapid construction did not compromise safety or effectiveness. The Seabees developed inspection procedures that could quickly verify the structural integrity of rapidly constructed facilities. They established maintenance programs that kept facilities operational under the harsh conditions of tropical combat zones. Training programs back in the United States continuously refined and improved Seabee construction techniques. Lessons learned in combat zones were incorporated into training curricula, ensuring that each new group of Seabees arrived in the Pacific with the latest innovations in rapid construction methods. The ultimate test of Seabee capabilities came during the most intense period of fighting for Henderson Field, a 72-hour ordeal in mid-October 1942 that would forever change the nature of military engineering. For 3 days and nights, Japanese forces threw everything they had at the American airfield in a coordinated effort to render it permanently unusable. The intensity and scale of this attack surpassed anything seen before in the Pacific War. October 13th began like any other day on Guadalcanal, with the usual morning reconnaissance flights and the routine maintenance that kept Henderson Field operational. But Japanese preparations for their massive offensive had been proceeding in secret for weeks. Admiral Yamamoto had committed the full resources of the combined fleet to this effort, determined to eliminate Henderson Field once and for all. The plan called for a carefully coordinated bombardment by battleships, followed by sustained bombing attacks and a ground assault by reinforced Japanese army units. At 11:45 a.m., the first wave of Japanese bombers appeared over Henderson Field. 25 twin-engine Betty bombers approached in perfect formation, their bomb bay doors already open. The air raid C. Wrens wailed across the airfield as Marines and Seabees scrambled for cover in slit trenches and bomb shelters hastily dug around the perimeter of the runway. The bombers came in low and slow, methodically placing their bombs across the entire length of the airfield. The first attack lasted only minutes, but when the smoke cleared, Henderson Field looked like it had been struck by an earthquake. Massive craters pockmarked the runway surface, some more than 20 feet across and 8 feet deep. Twisted fragments of Marston matting littered the area like oversized confetti. Several fuel storage areas had taken direct hits, sending towering columns of black smoke into the tropical sky. Before the repair crews could fully assess the damage, radar operators detected another formation of incoming bombers. The second attack came just 40 minutes after the first, with Japanese pilots deliberately targeting areas that appeared to be under repair. This time, the bombers focused on the areas where Seabees were already working to fill craters from the first attack, forcing the construction crews to abandon their work and seek shelter once again. The afternoon brought a third bombing attack, this one even more intense than the first two. Japanese intelligence had identified the exact locations where repair materials were stored, and the bombers targeted these supply dumps with devastating accuracy. Explosions rippled across Henderson Field as stockpiles of aviation fuel, ammunition, and construction materials were consumed in massive firestorms. The air became thick with smoke and the acrid smell of burning gasoline and rubber. But the worst was yet to come. As darkness fell over Guadalcanal, the distant rumble of naval gunfire began to echo across the island. Japanese battleships Congo and Haruna had approached to within close range of Henderson Field, their massive 40-inch guns trained on the airstrip. What followed was one of the most intense naval bombardments in the history of warfare. For nearly 2 hours, the two battleships poured shells into Henderson Field with methodical precision. Each 14-inch shell weighed over 1,400 pounds and could create a crater 30 feet across. The battleships fired over 900 rounds during the bombardment, turning Henderson Field into a lunar landscape of overlapping craters and debris. The concussion from the massive shells shattered equipment, collapsed buildings, and sent shockwaves through the ground that could be felt miles away. Between the thunderous crashes of incoming shells, the Seabees huddled in their bunkers and bomb shelters, listening to their life's work being systematically destroyed. The sound was unlike anything they had experienced, a continuous rumbling punctuated by earth-shaking explosions that seemed to go on forever. Men who had worked through German bombing raids in North Africa and survived Japanese air attacks since arriving on Guadalcanal found themselves tested as never before. When the bombardment finally ended at 2:15 a.m. on October 14th, Henderson Field had virtually ceased to exist as a functional airfield. The runway was obliterated, covered with craters so numerous they overlapped each other. Every building had been destroyed or severely damaged. Fuel storage areas burned out of control, ammunition dumps continued to explode sporadically, and the acrid smoke made it difficult to see more than a few yards in any direction. As the first light of dawn revealed the full extent of the devastation, any rational observer would have declared Henderson Field permanently out of action. The systematic destruction inflicted by the Japanese bombardment had achieved its goal. The airstrip appeared to be completely unusable. 53 major craters pockmarked the runway, some so large that they could have swallowed a truck. The carefully laid Marston matting had been torn apart and scattered across hundreds of yards. Support facilities lay in ruins, their twisted remains bearing testimony to the awesome destructive power of naval gunfire. But Lieutenant Commander Paul Blunden and his Seabees saw something different as they emerged from their shelters. Where others saw destruction, they saw just another construction job. Where others saw impossible damage, they saw problems with solutions. Within minutes of the bombardment's end, even before the fires had been fully extinguished, Seabee crews were racing onto the field with their pre-positioned trucks loaded with crushed coral and replacement steel matting. The repair operation that followed defied every conventional understanding of military engineering. Working under conditions that would have challenged peacetime construction crews, the Seabees began the seemingly impossible task of restoring Henderson Field to operational status. They had done this before during smaller attacks, but never on this scale, never with this much damage, never with this much at stake. The first priority was clearing the runway of debris and unexploded ordnance. Seabees worked alongside marine engineers and even volunteer cooks and clerks, forming human chains to remove twisted metal and shattered concrete. Unexploded shells and bombs posed a constant threat, but the work continued without pause. Every minute counted, as marine pilots waited anxiously beside their aircraft, ready to take off as soon as a usable runway became available. The crater-filling operation demonstrated the Seabees' revolutionary approach to rapid repair. Rather than attempting to restore the runway to its original specifications, they focused on creating a functional surface as quickly as possible. Teams of bulldozers worked in coordination, pushing fill material into the craters, while other crews laid temporary sections of Marston matting over the filled areas. The precision and coordination of the repair effort amazed even experienced construction workers among the Seabees. Different crews worked on different sections of the runway simultaneously, but their efforts were perfectly synchronized. Communication systems kept all teams informed of progress and priorities, ensuring that resources were allocated where they could have the greatest impact. As morning progressed into afternoon, the impossible began to seem achievable. Section by section, Henderson Field began to take shape again. The craters disappeared under tons of crushed coral and compacted fill. New sections of Marston matting were laid with the precision of a floor installation, each piece interlocking perfectly with its neighbors to create a smooth, hard surface capable of supporting the weight of fully loaded aircraft. The most critical moment came at 2:30 p.m. on October 14th, just over 12 hours after the devastating bombardment had ended. A Marine Wildcat fighter approached Henderson Field for an emergency landing, its fuel tank nearly empty after a reconnaissance mission. The pilot, Lieutenant Colonel Harold Bauer, had no choice but to attempt a landing on the hastily repaired runway, knowing that if the surface failed, he would crash and potentially block the runway for other aircraft. Hundreds of men watched in tense silence as Bauer's Wildcat touched down on the newly repaired surface. The Marston matting held firm, the filled craters supported this. Aircraft's weight, and the landing was successful. Within minutes, other aircraft were taking off and landing, proving that Henderson Field was not only operational, but capable of supporting full-scale air operations. The psychological impact of this achievement rippled through both American and Japanese forces. American morale, which had reached its lowest point during the devastating bombardment, surged back to new heights. The knowledge that Henderson Field could survive and quickly recover from even the most intense attacks gave every American on Guadalcanal renewed confidence in their ability to hold the island. For the Japanese, the rapid repair of Henderson Field represented a crushing blow to their strategic plans. They had expended enormous resources in the bombardment, including irreplaceable battleship ammunition and the services of their most experienced bomber crews. The attack had been designed as a knockout blow that would permanently eliminate American air power from Guadalcanal. Instead, they had achieved only a temporary inconvenience that was overcome in less than half a day. Japanese commanders found themselves facing a completely new kind of warfare, one in which their traditional advantages in planning and preparation were neutralized by American speed and adaptability. The carefully orchestrated bombardment had failed not because of poor execution or inadequate firepower, but because their enemy possessed capabilities that Japanese military doctrine had never anticipated. The strategic impact of the Henderson Field repairs reverberated throughout the Pacific Theater and fundamentally altered Japanese strategic planning for the remainder of the war. What had been conceived as a decisive blow that would eliminate American air power from Guadalcanal instead became a demonstration of American engineering capabilities that shocked Japanese military leadership. The speed and efficiency of the Seabee repairs forced Japanese commanders to completely reassess their understanding of American military capabilities. Within hours of Henderson Field's restoration, American aircraft were not only taking off and landing but conducting aggressive offensive operations against Japanese positions throughout the Solomon Islands. Marine and Navy pilots, inspired by the Seabees' incredible achievement, flew mission after mission with renewed determination. The psychological boost provided by the rapid repairs translated directly into increased combat effectiveness, as American air crews operated with the confidence that their base would always be available for their return. Japanese intelligence reports from Guadalcanal painted a picture that many commanders initially refused to believe. Field reports described American construction crews working under fire with an efficiency that seemed impossible by Japanese standards. Pilots returning from bombing runs reported that runways they had left in ruins were operational again within hours. Naval commanders who had expended precious battleship ammunition in devastating bombardments watched in disbelief as American aircraft resumed operations almost immediately. The failure of the October bombardment to achieve its strategic objectives forced a fundamental reassessment of Japanese tactics in the Solomon Islands campaign. Previous Japanese military planning had assumed that destroying enemy airfields would take weeks or months to repair, providing windows of opportunity for Japanese forces to advance and consolidate their positions. The Seabees' rapid repair capabilities eliminated these windows, forcing Japanese commanders to develop entirely new approaches to the problem of neutralizing American air power. Enemy reaction to American construction speed manifested in increasingly desperate attempts to inflict permanent damage on Henderson Field. Japanese engineers began developing new types of delayed action bombs designed to explode hours or days after impact, hoping to catch repair crews in the act of restoration. They experimented with chemical weapons intended to contaminate runway surfaces and make them unusable for extended periods. They even attempted to introduce time-delayed explosive devices into construction materials, hoping to destroy facilities after they had been repaired and returned to service. The psychological impact on Japanese forces was equally significant. Japanese soldiers and airmen had been trained to believe in the superiority of their military engineering and construction capabilities. The sight of American construction crews accomplishing in hours what Japanese engineers would have required weeks to complete challenged fundamental assumptions about Japanese technological superiority. This psychological shift contributed to declining morale among Japanese forces throughout the Pacific theater. American forces throughout the Pacific benefited from the lessons learned at Henderson Field. The rapid repair techniques developed by the 6th Naval Construction Battalion were quickly disseminated to other Seabee units, becoming standard procedure for airfield maintenance and repair operations. Training programs back in the United States incorporated the Henderson Field experience, ensuring that future Seabee deployments would arrive with proven techniques for rapid construction and repair. The success at Henderson Field also vindicated the entire concept of the naval construction battalions. Military leaders who had initially been skeptical of the Seabee program became enthusiastic supporters, recognizing that these construction fighting units provided capabilities that traditional military engineers could not match. Funding and resources for Seabee operations increased dramatically, allowing for expanded recruitment and training programs. Japanese attempts to counter American construction capabilities led to some of the most innovative defensive measures of the Pacific War. They began constructing multiple backup airfields on each island they controlled, hoping to provide alternatives when primary facilities were captured or damaged. They developed camouflage techniques designed to hide airfield construction from American reconnaissance, and they experimented with rapidly deployable runway surfaces that could be assembled quickly when American forces approached. The strategic implications extended far beyond the immediate Guadalcanal campaign. Japanese military planners began to realize that their island fortress strategy was fundamentally flawed when facing an enemy with American construction capabilities. The assumption that captured Japanese airfields would require months to restore to operational status proved completely wrong, as American forces consistently brought captured facilities back into service within days or weeks. The broader revolution in military engineering that emerged from the Henderson Field experience transformed the nature of warfare itself and established principles that would influence military construction for decades to come. The Seabees' achievement demonstrated that speed and adaptability could be more valuable than traditional engineering perfection, a lesson that would reshape military construction doctrine throughout the world. American military planners quickly recognized that the Seabee success model could be applied far beyond airfield construction and repair. The same principles of rapid response, pre-positioned materials, and standardized construction techniques were adapted for port facilities, roads, bridges, fuel storage systems, and virtually every other type of military construction. The Pacific War became a testing ground for revolutionary construction methods that would influence post-war infrastructure development throughout the world. The development of prefabricated construction components accelerated dramatically following the Henderson Field success. American factories began producing standardized sections of runways, bridges, buildings, and other facilities that could be rapidly assembled in combat zones. This prefabrication revolution reduced construction time while improving quality control, as components could be manufactured under ideal conditions and simply assembled in the field. Engineering education in American universities began incorporating Seabee construction techniques into their curricula. The rapid construction methods developed under combat conditions proved valuable for civilian applications, particularly in emergency response and disaster relief situations. Construction companies began adopting Seabee techniques for projects requiring rapid completion, creating a direct transfer of military innovation to civilian industry. International recognition of American construction capabilities led to requests for assistance from allied nations throughout the war. British, Australian, and Soviet forces all sought to learn Seabee construction techniques, recognizing their potential applications in their own military operations. The Seabees became unofficial ambassadors of American engineering innovation, spreading their methods throughout the Allied forces. The psychological impact of the Henderson Field repairs extended far beyond immediate military applications. American industrial workers gained confidence in their ability to outproduce and outbuild enemy forces, contributing to increased productivity in war production facilities throughout the United States. The knowledge that American construction workers could accomplish the impossible under combat conditions inspired workers in factories, shipyards, and aircraft plants to achieve new levels of productivity. Post-war analysis by military historians and engineers confirmed that the Henderson Field repairs represented a genuine revolution in military construction methodology. Traditional approaches to military engineering had emphasized permanence and precision, accepting lengthy construction schedules as inevitable. The Seabees proved that speed and functionality could be more valuable than perfection, particularly in combat situations where time was often more critical than durability. The lessons learned from Henderson Field influenced American military construction throughout the remainder of World War II and into subsequent conflicts. Seabee units became integral components of every major American military operation, providing construction capabilities that enabled rapid establishment of advanced bases and facilities. Their techniques were refined and improved through continued combat experience, but the fundamental principles established at Henderson Field remained constant. German military engineers, when they encountered American construction capabilities in Europe, expressed amazement similar to that of their Japanese counterparts. Reports from German prisoners described American bridge construction that violated every principle of traditional military engineering, yet proved completely effective in practice. The speed with which American forces could establish and maintain supply lines challenged German defensive strategies that had been based on assumptions of lengthy construction timelines. The technological innovations pioneered by the Seabees at Henderson Field continued to evolve throughout the war and into the post-war period. Improvements in materials, equipment, and techniques built upon the foundation established during those critical days in October 1942. The rapid repair of Henderson Field became a case study taught in military academies around the world, demonstrating the importance of adaptability and innovation in military engineering. The legacy of Henderson Field extended into the Cold War era and beyond, as American military construction capabilities continued to provide strategic advantages in conflicts around the world. The ability to rapidly establish and maintain military facilities in remote locations became a cornerstone of American military strategy, enabling the projection of power to distant theaters of operation. The remarkable achievement of the Seabees at Henderson Field represented far more than a simple victory of American engineering over Japanese firepower. It marked a fundamental shift in the nature of warfare itself, demonstrating that adaptability and speed could triumph over traditional military doctrine and overwhelming force. The men who restored that bombed airfield in October 1942 changed the course of history not through heroic charges or brilliant tactics, but through the quiet determination to do their jobs under impossible conditions. The tears that German engineers reportedly shed when they witnessed American construction capabilities were tears of professional recognition. They understood, perhaps better than anyone, the magnitude of what the Americans had accomplished. These were men who had built the Autobahn system, who had constructed the Atlantic Wall, who had created some of the most impressive military engineering projects in history. Yet they found themselves outmatched by American construction workers who treated the impossible as merely another day's work. The legacy of Henderson Field extends beyond military history into the broader story of human achievement. It demonstrates that ordinary people, when properly trained and motivated, can accomplish extraordinary things. The Seabees who worked through those 3 days of bombardment were not superhuman. They were construction workers, many of them middle-aged men who had volunteered to serve their country. What made them extraordinary was their refusal to accept defeat. their determination to find solutions to seemingly impossible problems. The speed with which they restored Henderson Field, turning 53 bomb craters into a functional airfield in less than 12 hours, established new standards for what human beings could accomplish under pressure. Their achievement inspired not only their military colleagues but also workers in factories and shipyards throughout America, contributing to the industrial mobilization that ultimately won the war. Today, the principles established by those Seabees continue to influence everything from disaster relief operations to space exploration. The idea that speed and functionality can be more valuable than perfection, that prefabricated components can enable rapid construction, that proper preparation and training can overcome seemingly impossible challenges. These lessons learned in the heat of combat have become fundamental principles of modern engineering and project management. The story of Henderson Field reminds us that behind every great military victory, every technological breakthrough, every moment when history pivots toward a better future, there are often ordinary people doing extraordinary work. The Seabees who restored that airfield in October 1942 changed the world not through grand gestures or brilliant innovations, but through the simple determination to complete their mission regardless of the obstacles they faced. Their legacy lives on in every rapid response to natural disasters, every emergency construction project, every moment when skilled workers accomplish the impossible because someone's life depends on their success.